All right, little redox prep for you guys. Please, if you are bumping, turn off your radio, your music. The stuff you want to be listening to is the reason why I'm even talking and walking you through these videos. All right. First question on my prep could be different than your order because, of course, I randomize these things. First part, voltaic cell, need to know that. So you know that it's got a voltmeter in the salt bridge. And then the rest of the stuff is lawyer talk. Just letting you know that it's operating under normal conditions, so nothing's crazy. Just like I showed you in the packet, look, here's your redox reaction going on. Identify the anode in this cell. We know we always go from A to C, right? And then the anode is going to be the one that's the most reactive. And I already know right off the dome, Ag is one of the three most least reactive metals. So without even looking it up, I know it's this right here. And it cannot be this. They want you to say this. Notice it's there. But this cannot be an anode. This is a liquid in aqueous. We know it's not silver. We know it's not silver. We got to choose between the two nickels. And it's going to be the solid piece. That's what an anode is. Or a cathode. They're both the solid pieces. Which energy conversion occurs in operating on an electrolytic cell. All right, so when we compare and contrast these things, the voltaic cell is taking chemical energy and turning it into electric energy. The opposite is true. An electrolytic cell is taking electric energy and turning it into chemical energy. We didn't talk about anything about thermal. We didn't talk anything about nuclear. So here's our two. It's which way it does it go. And you cannot get them backwards. You guys got to come up with a way to memorize, not realize, memorize that voltaic takes chemical energy and turns into electrical energy. Electrolytic takes electric energy and turns it into chemical energy. All right, what is the oxidation number of manganese? This guy here. So this is the top and bottom guy that we've been doing before. Up top, I know oxygen is a -2. -2 times 4 is a total -8. K is always a +1. So I got a 1 plus an X. -8 equals 0. So X has got to be 7. And I know that because this whole term here has got to be 8. So it's 8 minus 8 equals 0, obviously. And 1 plus what number gets me up to 8? That'd be 7. So there's my answer. Bop, 7. Okay, which metal will react spontaneously with Zn, but not spontaneous with Mg? Okay, so will react spontaneously with Zn, which means it's higher on table J, but it's got to be below Mg. Okay, I can see that copper right off the bat is going to be a no-go because we know copper is one of the three metals that is below H, but I can't do this without table J to be sure. So I'm opening up my reference table. I find Zn, okay, and I find Mg. And in between those, I see aluminum Al, Ti, and Mn. And so Mn is my answer. Cu is below it. Nickel is below Zn. And Ba is above both of them. So it'll spontaneously react with both. Okay? Given the balanced ionic equation representing blah, 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 follow the electrons through the electrical circuit. This cell is from the, so who's the anode, who's the cathode? All right, so we know red cat, angry ox. I don't want to take the time to write it, but I'm just going to say it. Red cat, angry ox. So I know I go from reduction at the cathode, so electrons go from anode to cathode. So I got to find out who's the anode and who's the cathode. So I got this guy and I got this guy. These guys are aqueous solutions, so they cannot be the anode or the cathode. And copper is one of the three below hydrogen, least reactive. So I know Zn is the anode. Copper then is the cathode. So where do I find Zn is the anode? There it is. Zn is the anode. Cu is the cathode. This is us right here, C. That's how we do it. Notice it just gives you all four possibilities. So you really do have to know your stuff, which is okay. We do know our stuff. We know it goes anode to cathode, A to C, and we know red cat, angry ox. The anode is going to be the more reactive on table J. So it's actually not that hard to figure it out. Hey, who's more reactive and less active? More active than Ni. So who's above nickel? I'm looking for Ni on table J. I see it. Less active than Zn. I see Zn. So less active than Zn is CrFeCO. So who's here? CrFeZO. More reactive than nickel, but less reactive. Cr. Oh, Cr. Duh. Here it is. I was just having trouble finding it. I was saying it 3 times. I was having trouble finding it. During the operation of a voltaic cell, the cell produces electrical energy. Okay. So we know we don't produce chemical energy. We produce electrical energy, and voltaic is spontaneous. So there you go. Knowing all the definitions of voltaic cell. What is the correct balanced half reaction equation for reduction that occurs in this cell? Figure 1. Uh-oh. Where's figure 1? Oh, that's this guy here. So these questions are out of order, unfortunately. Let me just scroll down, see if there's another figure 1. Nope. So these two questions should have been together. This question and then this question. But that's okay. What is the correct balance reaction for reduction? Reduction is gaining. Oil rig. I'm not going to take the time to write it. So gaining. Here I have electrons gaining. Here I have electrons losing in B. I have electrons gaining in C. I have electrons losing in D. So I can't have electrons losing. Product side is losing, remember. Okay, so then which one makes sense? Reduction is gaining, but reduction also has to have my charge going from, this is a 0 to a +2. This is not a reduction charge. So this doesn't make sense. If I have a nickel and I add 2 electrons, this should be negative, not positive. So that's where this one's off, and this one is where I want to go. I could actually do this without looking at the cell, just because I know oil rig. All right. Oxidation number of chromium, but this guy has a charge, so I know the whole thing equals -2. And then we start with our oxygen. Oxygen is a -2. -2 times 8, I'm sorry, times 4 is a -8. Chromium is my X. What number -8 gets me a -2? Well, that's going to be 6. 6 minus 8 is a -2. There's my 6. Voltaic cell. Ions move through the salt bridge. Remember, they want to get you to say electrons move through the salt bridge. No, 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 no. Electrons move through the circuit, through the anode and the cathode, but the salt bridge lets the ions replenish. The number of electrons lost must equal the number of electrons gained. So we can't have this, can't have this. Definitely, look at that word, protons. Definitely not there. Definitely A. I drop $2, you pick up $2. We should have that one, that part pretty locked in. Which half reaction represents reduction? Rig. Reduction is gaining. So electrons on the product side is losing. Electrons on the product side is losing. So we know it's B or C. And then I have iron 2. So the iron's got to have the +2 charge right here. Otherwise, this would say iron 3. So that's a little bit of bringing back bonding and how we name these things. But we definitely can't. And then reduction, we also know both of them that their charge is going down. But iron 2 goes to iron 0. Got it. Given the balanced equation, blah, 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 during this reaction, the oxidation number of Fe changes from. So here we just have to put up our charges. Lone element over here is 0, and they all have 0. This is good. But look at this. Protons. Protons are not what's being transferred. We know it's electrons, so I can get rid of B and D. And then I have to do this guy right here. They're all zeros, so that's my 0. I'm going to use oxygen's a -2. -2 times 3 is a -6 total. That gives me a +6. Going back up, we divide. 6 divided by 2 is a +3. So iron is a +3. Got it. Which half reaction equation represents the reduction? Again, Rig. Reduction is gaining right off the bat. These electrons I'm losing, so it's not C or D. Which of a potassium ion? Well, this is not a potassium ion. This is a potassium with a 0 plus an electron. That should be negative, so this thing is wrong. There's my potassium ion going from a +1 to a 0. That's a reduction. My charge is going down from +1 to 0. Perfect. Based on table J, two reactants react spontaneously. I need the lone metal to be higher than the bonded metal. I know right off the bat B is wrong because copper is one of the least reactive metals. Okay. Is Mg higher than Cn? And the answer is yes. So this is my answer. Uh-oh, and kids are coming in. So let's see if I can finish this video. Oxidation number of iodine. So this is another one to find the middle guy. So go with what I know. K is a +1. Oxygen is a -2. -2 times 4 is a -8. So now solve for X. 1 plus 7 is going to get me to 8. 8 minus 8 is 0. So it's going to be a +7. You don't even have to, if it's not on your periodic table, it's still the right answer because the math proves it, by the way. Oxidation state of chlorine in this reaction changes from, this one's a toughie. So here I know it's a -1 right off the bat. K is a +1, chlorine's a -1, so that gets rid of A and B. So now I got to figure out this guy, KClO3. We know K is a +1. Oxygen is a -2, which is a -6. That gives me my X in the middle has got to be a 5. 1 plus 5 is 6. 6 minus 6 is 0. So 5 to -1. There we go. That's my answer. A few more problems and we's done. Which energy change occurs in a voltaic cell? Voltaic cell is a chemical energy to electrical energy. Chemical to electrical. Here we go. 19. Which half reaction represents reduction? Man, I got a lot of reductions on this thing. Rig. Reduction is gaining. Gaining electrons is not here. That's losing. This is losing. So we're cutting off A and C. Which half reaction represents a reduction that occurs? So now is it A reduction? This is a reduction. Perfect. Going from 3 to 0, that's going down. Going 2 to 0 is going down. Okay. Now we got to actually use this equation. So I got AL0 and a CU0. B cannot be right because AL is starting out as a 0 and here it's a +3. So that's not right. Cu is a +2 and Cu is going to 0. So that's the answer that I'm looking for. In a redox reaction, the number of electrons lost is equal to the number of electrons gained. Man, this is a similar question that was already on this prep, except for the answer's slightly different. We know it's not protons, and it's definitely not neutrons. It's definitely electrons gained. And with that, we are done with the video.